solve this problem. First we will calculate what is the area of steel. So AST is equal to, it is 4 into pi by 4 into 16 square. Do the fast calculations. Okay. So it is, what is the answer? It is 804.24. 804.24 mm square. This is the area of steel. Okay. Now after this we will equate Cu equal to Tu. Now all of you are familiar with these terminologies. Cu is the total compressive force, Tu is the total tensile force. So what is the formula for Cu? It is 0.36 FCK B into XU, which is equal to Tu is 0.87 Fy into AST. So just put the values to get the value of XU. So this is 0.36 into FCK is 20 into B, width of section is 250 into XU as it is, which is equal to, it is 0.87 into Fy is 250, okay, into AST, area of steel is 804.24. So solve this, we will get the value of XU over here, 7, okay. So 97.17 mm. This is the value of XU. Okay. Now calculate the XU max. I have already told you how to calculate XU max. So now we know that from IS code. We have already seen that clause. I think on page number 70 or 71 you will get this. XU max by D is equal to, now Fe250 is given. So for Fe250 it is 0.53. Okay. So now from this XU max is equal to, it is 0.53 into, what is the effective depth given? The effective depth is 450. So multiply this by 450. So therefore what is the value of XU max? 238.5. Okay. So it is 238.5 mm. So now see who is greater and who is less. Okay. So here XU is again less than XU max. When your XU is less than XU max, your section is what? It is under reinforced section. This is under reinforced section. Now if the section is under reinforced, then what formula we are used to calculate the moment of resistance? Then mu is equal to, the formula is, it is Tu into Z. So therefore mu is equal to, what is the value of Tu? Again it is 0.87 Fy AST, that is the tensile force, multiplied by Z. Z is the lever arm, D minus 0.42 XU. Okay. Now just put the values, you will get the value of mu then. So mu is equal to 0.87 into 250 into AST is 804.24 into D minus 0.42 XU, D is 450 minus 0.42 into, what was the value of XU we have calculated? 97.19. So 97.19. So if you put the value, you will get the value of mu. Mu is equal to, now let me know the value of mu. What is the answer? 71.57. Okay. So 71.57, this is the value of mu, 71.57 kilonewton meter. So this is the moment of resistance what we have found out. So this is one type of problem. Okay. In these types of problems, what we generally do, we calculate the XU from the given data, we calculate the XU max, we compare both of them, and accordingly we will decide that which formula is used to calculate the moment of resistance, whether we are going to use Cu into Z or Tu into Z, and in that way we calculate the moment of resistance. So this is the one type of problem. Now we will take another type of problem. Next problem. So now the next numerical is a singly reinforced beam. A singly reinforced beam 300 by 500 mm with with clear cover of 40 mm is reinforced with is reinforced with 4 bars of 20 mm diameter. 4 bars of 20 mm diameter. Full stop. Find find the flexural strength. Find the flexural strength and safe UDL and safe UDL uniformly distributed load on simply supported beam on simply supported beam of span 5 meter of span 5 meter. Use M20 and FE 500. So this is the given numerical. Now we will read the numerical once again. A singly reinforced section is there. Okay, 300 by 500 mm is its dimension, width and depth. So overall depth is given to you. Along with that, they have told you that the clear cover is 40 mm and is reinforced with 4 bars of 20 mm diameter. Okay. Find the flexural strength. Flexural strength means again moment of resistance. This is called as MU limiting also. Moment carrying capacity also. This is the name. And then flexural strength. This is also the same thing. So four names are there. Moment of resistance, MU limiting or limiting value of moment. MU limiting means limiting value of moment. Then your flexural strength and moment carrying capacity of the section. It is one and the same thing. And safe UDL. Now they have told you calculate the safe UDL. Span is given and grades of concrete and steel is given. Now further how we will solve this? Okay. So now to solve this, first of all, what we will do, as usually we will calculate the value of XU, we will calculate the value of XU max, and then we will calculate the value of MU. But before going to that, we know that what is depth. Overall depth is given to us, it is 500 mm. Okay, and what is clear cover? Clear cover is equal to how much given? It is 40 mm. And what is bar diameter? Bar diameter or tendon diameter, it is bar diameter is given to us as 20 mm. Okay, so therefore what will be our effective depth now? Effective depth is equal to your overall depth minus your clear cover minus half of bar diameter. So this is 10, 40, 10, 50, 500 minus 50, it is 450. 450 mm is your effective depth. This is your effective depth. Now what will be the area of steel AST? So AST is equal to 4 bars are given, each of bar diameter 20 mm. So 20 square. Let me know the answer. 56.63. Okay. So 1256.63 mm square. This is our value of area of steel. Okay. Now after this we will calculate XU. So to calculate XU, what we will do? We will equate total compressive force to the total tensile force. So now once you equate that, what you will get, it is 0.36 FCK B into XU must be equal to 0.87 Fy into AST. So 0.36 into FCK is 20 into B is, how much is the width? 300. So 300 into XU as it is, which is equal to 0.87 into Fy is 415, I think. 415 into AST, just you have calculated, it is something 1256. It is 1256.63. Okay, so Fe 500 is given. Sorry, I have written over here 415. Fy is 500. Fy is 500. Okay. Now let me know the answer for XU. Therefore, XU is equal to what value? 253.07. 253.07. Okay, so this is the value of XU. Now calculate XU max. So XU max divided by D is equal to, it is how much? 0.46 for Fe 500. How much it is? 0.46. Okay, so therefore XU max is equal to, XU max is equal to 0.46 into D. So D is 450, which is equal to 207 mm. Now see the thing. Who is greater and who is less now? Now here our XU is greater than XU max. Okay. Now here in this case, your XU is greater than XU max. What does it imply? It is the over reinforced section. This is over reinforced section. So in the over reinforced section, first concrete fails, and that is very dangerous because concrete is brittle material and it fails suddenly. Concrete failed due to crushing. Are you getting my point? Whenever we get the under reinforced section, then in under reinforced section, steel will fail first, and steel is the ductile material, and it gives us a sign before failure. Steel does not fail suddenly. That is the difference. This is the concept. You understand this? Now over reinforced section. So XU is greater than XU max. Over reinforced sections. Now listen care. Now see here carefully what I am writing. So generally we avoid, what do we avoid? We avoid to design over reinforced section. Generally, we avoid to design the over reinforced sections. Okay. Generally, we avoid to design the over reinforced sections. We can't design over. We cannot design over reinforced sections. So what we will do that then, therefore therefore we will assume this section as balance section. Okay, therefore assume balance section. Okay, what we will assume, this is the balance section. Okay, so therefore we take xu is equal to xu max, which is equal to, what was the value, it is 207.207. xu max ची व्हॅल्यू किती आलेली आहे 207. ही व्हॅल्यू आपण घेणार नाही xu ची. का घेणार नाही, तर आपल्याला ओव्हर इन्फोर्स सेक्शन डिझाइन करायचा नाहीये. वी नेवर डिझाइन ओव्हर इन्फोर्स सेक्शन. जेव्हा जेव्हा अशी कंडिशन येईल, यू कम अक्रॉस दिस ओव्हर इन्फोर्स सेक्शन, we always design over info sections by assuming it as a balanced section. Keep this in mind. And why we don't design over info sections, I have already explained you. Concrete fail first in the over info section. Okay, and concrete is a brittle material and its failure is the crushing failure. So suddenly the structure fail होते. मग तुम्ही कधी कधी जे न्यूज ऐकता ना, कुठेतरी भिंत पडली, स्लॅब पडला, बीम खाली आली, that is the failure due to the over reinforced sections. If those sections are designed as under reinforced sections, then they won't fail suddenly. They will give you the sign before failure. Okay, so xu is equal to xu max and that value is 207 mm. So this is the value. Now in the balance section, what is the formula to calculate the mu? So therefore moment of resistance, your mu or mu limiting or mr, okay, it can be calculated as, it is cu into z. So mu limiting, which is equal to, here it is 0.36 fck b into xu max into d minus 0.42 xu max. Okay, so here if we put the values, then mu limiting, that is mr, moment of resistance, 0.36 into fck, it is 20, into b, what is the value of b, b किती दिलेले बघावं लागेल. So b is 300, so it is 300 into your xu max 207 into d, depth is 450. What is our depth? It is 450 minus 0.42 into 207. So if you solve this, you will get the value of mu limiting. Find out that value. 62.33 kilonewton meter. Okay. So it is mu limiting, or this is also, we call this as a mr. What value we have calculated? 162.33 kilonewton meter. So here our problem doesn't end at this point. Okay, what they have further told you to calculate? Further they ask you, after the calculation of this flexural strength, after the calculation of this flexural strength, you need to calculate the safe UDL on simply supported beam of span 5 meter. So safe UDL we need to calculate. Here if I draw the beam, now this is the beam, this beam is simply supported, so this is the simple support. What is the span of the beam? The span of the beam, this span, it is given to us as 5 meter, and we need to calculate the UDL. Let W be the UDL which is acting on the beam. Let the UDL is W kilonewton per meter. This is the UDL. Okay, this is the UDL. Now we know the moment of resistance of the beam. What is the moment of resistance? See, there is a difference between bending moment and moment of resistance. What is the moment of resistance? Moment of resistance is the extreme value of bending moment. Okay, that can be resisted by that section. That is called as moment of resistance. And bending moment, it depends upon your span and load of the section. Bending moment may be equal to mr, or bending moment may be less than mr. Okay, but mr is having the fixed formula, moment of resistance. You know that formula. It depends upon the grade of steel and grade of concrete. 0.138 fckbd square or 0.149 fckbd square. So if you see this formula, so mr it is not depending upon your, what we can say, length and load. Okay, load is acting and what is the length. So that is the moment carrying capacity, and bending moment is what is the length of the member, what is the load acting on the member, and accordingly that load produce the rotational or bending effect on that beam, and that bending effect is nothing but the bending moment. So the maximum bending moment is equal to moment of resistance. Okay, so bending moment maximum कुठपर्यंत जाऊ शकते, तर up to moment of resistance. So bending moment may be equal to moment of resistance, that is the maximum value of bending moment, and it can be less than mr. Okay. So now here this is the beam. Now what is the formula to calculate the maximum bending moment of this beam? So if I want to calculate the maximum bending moment, so you know that this beam is simply supported carrying UDL. So what is the maximum bending moment? It is WL square by 8. So which is equal to W, we don't know. I will keep it as it is. Okay, I will keep it as it is, W into L square. L we know 5 square divided by 8. This is the maximum bending moment. So lastly, we will equate our maximum bending moment to moment of resistance. So here equating maximum bending moment to moment of resistance, or MU, limiting moment of resistance. So therefore it is 162.33 into 10 to the power 6. No, there is no need to do 10 to the power 6. We will calculate the load in Newton. Sorry, kilonewton. So this is in kilonewton meter, 162.33, which is equal to W, I will kept as it is, into 5 also I will kept it in meter. So we will get W in kilonewton per meter divided by 8. So therefore your safe UDL W is equal to, so this is your UDL. What is the value of W now? It is 51.95. Okay, so 51.95 kilonewton per meter. Okay, so this is your working load. So this is your service load, not a working load. This is the service load. Okay, so this is your ultimate load. Now they have asked you to calculate the safe UDL. Okay, they have asked you to calculate the safe UDL. Okay, so safe UDL means working load. So safe UDL, how do we calculate that? So therefore safe UDL is equal to service load, or this is called as ultimate load, divided by factor of safety. So which is equal to, it is 51 point something, 51.95 divided by factor of safety is 1.5. So your safe UDL will be, what is the answer? 34.63. So this is your safe UDL, 34.63 kilonewton per meter. So this UDL is your safe load, safe UDL. Okay, so this UDL is the same. So I hope now you understood the things. So up to the calculation of MR, the steps are same regularly what we do. Generally in previous two problems also we have done that. Then after that you need to calculate the bending moment depending upon the given condition. If the beam is given to you as a cantilever beam, then you should use the formula WL square by 2. Okay, now it is simply supported beam, we have used the formula WL square by 8. Likewise, whatever the boundary conditions are given, based on that you need to use the formula and you need to calculate the bending moment. After calculating that bending moment, you equate that bending moment to moment of resistance. Okay, so after that you equating, you will get the value. Okay, so now this is the third problem. One more problem we will take, somewhat somewhat difference is there. So now whatever I am taking now, these problems are asked in the examination, means for theory paper. Now if your examination is online, then these numericals will not be there, but they may ask you the one step numerical. That is, now suppose this safe UDL, they may ask you the service load is 51.95 kilonewton per meter. What will be the safe load on the structure? So in that case you need to divide it by 1.5. I am just giving you the example how the MCQ can be asked. Okay, so please do understand each step, so there will not be any confusion. Then in which way the question may be asked, you will be able to give the answer. So now next problem is a singly reinforced beam 250 mm by 500 mm is reinforced with 4 bars of 16 mm diameter with with effective cover with effective cover of 50 mm. Now here effective cover is given directly 50 mm, full stop. Effective span of beam is 6 meter. Take M20 and Fe250 and Fe250 to determine central central concentrated load central concentrated load P that can be carried that can be carried by the beam by the beam in addition to its self weight. In addition to its self weight. Okay. So this numerical is given to us. So we will read the problem first and then we will solve. So what is the given data? Beam is there 250 mm by 500 mm, reinforced with 4 bars of 16 mm. Here the effective cover is 50 mm. This is the point. You remember this. What is given? Effective cover is given. Okay. They have not given us here. If I underline this, effective cover is given. So clear cover इथे दिलेलं नाहीये. Clear cover is not given. If clear cover is given, then you have to do from total depth. You need to minus the clear cover and then half of bar diameter. But effective cover means what? It is by considering the half of bar diameter, it is given to you. That is called as effective cover. Okay. So effective cover is given to you, and then effective span of beam is 6 meter. 6 meter span is there. Take M20 and Fe250 to determine the central concentrated load P. So on that beam centrally a point load is acting, which is having magnitude P, that can be carried by the beam in addition to its self weight. So this load is carried by the beam in addition to its self weight. So excluding the self weight of the beam. Okay. And now here the condition is not satisfied, where they have not specified that which type of beam it is. Simply supported, cantilever, overhang, the thing is given. So it is now in our hand. We can assume any condition, we can assume it is simply supported for our simplicity. Okay. So in the 99% of numericals, they specify the condition. It is simply supported, or if it is it is of any other type. But now here the condition is not given, so we will assume whatever we want. So now first of all, we will calculate AST, area of steel. So AST is equal to, how do we calculate that? It is 4 bars of 16 mm diameter. What is the value of AST? 804.24. Okay, so it is 804.24 mm square. So this is our area of steel. Okay. Now after calculation of the area of steel, we will calculate the effective depth. So effective depth small d is equal to, what is our overall depth? Overall depth capital D is 500 minus now effective cover 50. So it is not a clear cover. जर तुम्हाला प्रॉब्लेम मध्ये नुसतं कव्हर म्हटलं असतं, कव्हर ऑफ 50 mm और सपोज नाव क्लिअर कव्हर ऑफ 50 mm असं जर दिलं असतं तर तुम्ही काय केलं असतं? इन दॅट केस वी हॅव टू मायनस दिस 500 मायनस 50 मायनस तुम्हाला 16/2 करावं लागलं असतं बार डायमीटर इन द केस ऑफ क्लिअर कव्हर, or if only cover. These types of words given in the problem. Now, but they have directly given to you the effective cover. So just you need to minus this effective cover. So it is 450 mm. So now again do the same procedure. Okay. So equating, assuming the balance section, equate Cu equal to Tu. So it is 0.36 FCK B into XU, which is equal to 0.87 Fy AST. Just put the values and let me know the value of XU. 97.17. Okay. So the value of XU is 97.17. Now calculate XU max. So now Fe 250 is given. Okay. So it is 0.53 D. Now XU max we will calculate. What is the formula for XU max? So XU max is equal to 0.53 D, which is equal to 0.53 into 450. Again it is, how much it is? What is the value? 238.5. Okay, it is 238.5 mm. So who is greater, who is less? So here XU is less than XU max. So therefore, under reinforced section, this is under reinforced section. Okay. So now calculate the value of mu. Therefore, mu is equal to, it is Tu into Z. So mu is equal to Tu 0.87 FYAST into D minus 0.42 XU. So calculate the value of this mu, 71.57 kilonewton meter. Okay, so up to this part it is common. Now after this, what they have told us. Now here first I will see that assume assume the beam is the beam is simply supported, as no condition is given in the problem. So now if we consider this simply supported beam, and this is the support. What is the span of the beam? This span, it is given as 6 meter. Okay. And at the center a point load is acting, and its value is P. We don't know the value. Okay. Now see, you know the cross section of this beam. What are the cross section dimensions? What are the cross section dimensions? 500, not something, 300 by 500 or 250 by 500? 250 by 500, okay. So cross section dimensions are 250 by 500 mm. So first we need to calculate the self weight of the beam, because this load which is acting, it is excluding of self weight. हा तर लोड असणारच आहे, प्लस इथं काय असणार आहे, तर सेल्फ वेट ऑफ द बीम, या बीमचं स्वतःचं वेट असणार आहे काहीतरी. ओके, सो दिस इज नथिंग बट युअर self weight of beam, self weight. So now here I will calculate self weight is equal to, cross section dimensions are 0.25. We will calculate per meter length. So instead of 6 meter, we assume the length as 1 meter. So 0.25 into zero point 0.5 into 25. So we will get the dead load. How much it is? 3.125. 3.125 kilonewton per meter. Okay. Now calculate the ultimate load. This is the self weight. Okay, this is the just weight, normal load. Then ultimate load or factored load. So multiply this by 1.5. That is the factor of safety. So the answer is, I think, 4.68. 4.68 kilonewton per meter. This is your ultimate load. Now maximum bending moment. Okay. So bending moment maximum. So see, now two types of loads are acting on the beam. First is the UDL, that is the self weight, and second is the point load. Okay. So what are the formulas for simply supported beam? First, if I take for the UDL, then it is WL square by 8 plus for the point load, if we consider the magnitude as P, then it is PAB by L, or otherwise it is WAB by L. Notation doesn't matter, just understand the concept. So it is PAB by L if P is the load. So PAB by L is the formula for the point load, which is acting anywhere on the simply supported beam. Okay, it may act at the center or it may act at anywhere. So now your maximum bending moment is equal to W, it is 4.68 into L square, that is 6 square, divided by 8 plus P as it is into AB. A means from left hand distance and B means from right hand, divided by L, it is 6. So in terms of P, you will get the maximum bending moment, which is equal to, it is how much? This is 21.06 plus, here it is 1.5 P. Okay. Now equate the bending moment maximum to moment of resistance. So equating maximum bending moment to moment of resistance. So what is the maximum bending moment now? 21.06 plus 1.5 P. 21.06 plus 1.5 P, which is equal to, what was the MU? 71.57. So it is 71.57. Make sure that all the units are same. Therefore, now calculate the value of P. What is the concentrated load? 33.67. 33.67 kilonewton. So this is your final answer. 33.67 kilonewton. Okay, so all the varieties for the moment of resistance problem is over. So in the next lecture we will take one design problem